Algebra II 2.1c, Principle of Zero Products. When we multiply two factors, if one of the factors is a zero, the product's going to be a zero. And if the product's a zero, that means one of the factors must be a zero. See? If we don't know what is multiplied to 3, but our product's a zero, it's got to be a zero. And if we have a statement that says A and B must both be true or both be false, we can abbreviate the statement as A if and only if B. It's the same thing as saying if A then B and B then A. We're going to make some more sense out of this in a second. So I have a theorem for you. It's the principle of zero products. It says for any real numbers A and B, A times B equals 0 if and only if A is 0 or B is 0. For that product to be 0, either this or this has to be a 0. And the expression if and only if is sometimes abbreviated as IFF. So if you see IFF, don't think it's a misspelling. Don't think it's a typo in the book. It means if and only if, okay? Or if someone writes it. You've seen baby crib mobiles, right? And they hang in the baby crib and they go around, they have music and the baby can look at it. Well, for each little owl to hang at the same height and for the crib mobile to stay balanced, they need to be equal weight. If one of these little owls weighs more than the other three, then the whole thing is going to tip. Well, this is like an equation. And we can use the principle of zero products to solve each equation separately. If this product is 0, then either x minus 2 equals 0 or x plus 4 equals 0. One of them has to equal 0 in order for that 0 to be there. We can solve each one separately. One of them must be 0. It has to be because the product's 0. All right, so I have a few examples for you. We're going to do the x plus 4 times x minus 2 as our first example. And we set each one to equal 0. And we start using additive inverses to isolate the variable x. So because this is a plus 4, we take away 4 from each side and we get x is equal to minus 4. And on this side, because it's a minus 2, we add 2, and we get x equals a positive 2. We plug in these values for x into the original equation for each one, for each set of the parentheses. So we're going to plug in negative 4 into here and see what happens. And we get negative 4 for x and negative 4 for x. See how I did that? So negative 4 plus 4 makes a 0. Well, we don't need to do anything else because no matter what this is, we're multiplying 0 times whatever number that is, it's going to be a 0. So we don't even need to do that math. On this side, we're going to set x to equal 2. So instead of x plus 4, we got 2 plus 4. Instead of x minus 2, we got 2 minus 2. Well, right away, we see that this makes a 0 pair. So we don't even need to do this math. We know 0 times whatever this is going to be a 0. So both numbers worked. And there's two solutions, a negative 4 and a 2. And we can write the solution as a set inside of braces. It's called set braces. And our solution set is negative 4, comma, 2. See that? And do you see where I split them up to equal 0? Right down the middle of where they were being multiplied together? Well, that's what we're going to do to this one. We're going to split it right here between the 7a and the parentheses. So 7a equals 0. Well, 7 doesn't equal 0. And in order for this product to be 0, one of them, either the 7 or the a, has to be a 0, so we know it's the a. We don't need to check it because we can see a equals 0, all right? But let's check this side. So we set 4a plus 2 to equal 0, and we start isolating this a, so we can subtract 2 from each side to get rid of this plus 2, and we get 4a minus 2. Now we can divide each side by this coefficient 4 to make our buddy identity property invisible 1. We get a equals negative half. And we plug in that negative half into the original equation, into this original equation. And everywhere there's an a, we put a negative half, and we start doing the math. The minute we see that one of them is going to make a 0 pair, we know that whatever this is times 0 is going to be 0, so we don't even need to continue the math. One of them is a 0, then the whole thing is a 0, right? So there's two solutions for a. It can be a 0 and a negative half. That's our solution set, all right, for this one. Let's try it again. Now we've got negative 2a plus 5 times 5a plus 1. And we're going to set this to equal 0 and that to equal 0. And then we're going to start doing additive inverses to isolate the variable a. So this has got a plus 5. We're going to take away 5 from each side. That gives us a negative 2a minus 5. We're going to divide each side by this negative 2 coefficient. And that's going to give us a 1a equals 5 halves. This negative and negative makes a positive 5 halves. And on this side, we've got it set to equal 0. And to get rid of this 1, we're going to subtract 1 from each side. So we get a 5a equals negative 1. We can divide each side by that 5 coefficient. Creates identity property 1. We have an a equals a negative 1/5. So we plug in 5 halves into the original equation up here, wherever a is, and we plug in negative 1/5 into the original equation. We're hoping that one of them is going to make a 0. And when we look over here as plugging in the 5 halves, it gives us a negative 10 over 2. That's a negative 5 plus 5. That's our 0. So it doesn't matter what the math is on this side. We know whatever it is, it's going to be multiplied by 0, so the answer's got to be 0. So that worked. And you can do the math if you want. And on this side, we plug in the negative 1/5, wherever there's an a. And we see here that 5 times negative 1/5 gives us a negative 5 over 5. Well, that's a negative 1 plus 1. That made a 0, which means whatever's on this side multiplied to that 0 is going to be 0. So we have two solutions, 5 halves and negative 1/5 for our solution set. See that? I know this can be confusing, but practice makes perfect, okay? Well, perfect practice makes perfect. Our next video is going to be 2.2, and we're going to translate words into equations. So I'm going to actually have phrases from word problems, and I'm going to show you how they actually translate into an equation, okay? And if you click on the description of this video, you're going to be able to see a link to my Algebra 2 playlist that's growing every day. I add videos to it, all right? And you'll be able to do chapter tests and reviews by just going to that playlist and seeing what's happening, all right? Okay, let's start translating some words into equations for word problems. I hope I'll see you there. Bye.